Hello. Okay, today I want to show you how to check your work with a graphic calculator. It won't check everything, of course, but it's super useful. Sometimes that it's really good is if you're simplifying something. Maybe you have y equals something something, you do calculations, and you want to know, okay, did I get the right answer here? Is this simplified? We're saying down here it's kind of the same thing. We've got an equation of quadratic. This is standard form, and we want to know, is that simplified? Okay, or did I make a mistake somewhere? I did right there with that 18. But is that the only mistake? So, what we're going to do is we're going to draw graphs of both the question and the answer. And if things are right, the graphs should look identical, and if there's a mistake, the graphs will look different. So, just a little bit of review on how to use this guy. We're going to put equations into y1 and y2. We need to set the windows so that it's more or less, so the parabola is more or less on the screen. So if you press window, these settings right here, from -10 to 10 on x and y, those are good settings. If you're not sure where to start there. And the x scale and y scale you can put at 1 as well. Now if you press graph, right now you may have dots in here from the stuff we were doing in class. If you want to turn those off, you go up to stat plot. So on this calculator it's blue, so that means I press the blue button and then that button. You should get this screen. And then any of these plots that are on, you want to turn them off. So just press enter, and then go over here to choose off, and enter again. And then you can quit. So there we go, my dots are gone. Okay, so here's the question. Are these two things the same? So, did I correctly simplify this first line to get the last line? So what I'm going to do is in my y equals, I'll put the first line in the first one, x minus 2 times x plus 1. Okay, and then I'll put my answer in the last one, 3x squared minus 3x plus 6. Okay, so the idea is that if these are the same, if we've done all our algebraic operations correctly, then these two things should be identical, so the graphs should be identical. So you just check. So in this case I have two different parabolas. So these are not the same. So this is wrong. Another interesting thing, this is actually really useful to help you find a mistake if you know there is a mistake. If I now go back and graph the first line and the second line, if those are if those are different, that means that here's where I made the mistake. If those are the same, that means that the second line's okay and the mistake is in the last line. So if you're curious, you can either try to spot it or you can do that, and that'll tell you at least what line the mistake is in. So another example, I'll get rid of those. If I've got this example here, I want to know if I've done this right. So I'll graph the first one, x plus 3 squared minus 1. I got them in the wrong order there, that doesn't matter. So 2x squared plus 12x plus 17. So if I've done all these steps correctly, then these graphs should look identical. Watch, this is the thinking button. Good, so it's done, and what it's done is actually graph two graphs right over top of each other. So that means this is perfect. Of course, the one time that this won't tell you if you've made an error is if you have one graph here, say, and then another graph that's different, but it's so far off the screen you can't see it. But for the kinds of mistakes people make, this is pretty good at catching them. So this means this here is right. Correct. Okay. So here's your work. Let's see. There's your assignment. So I want you'll probably want to pause this in a minute, and so you've got these 6 questions, and I want you to simplify them. So, here it'll be multiplying out the brackets. What do you do with this -4 is a question. How do you do this squared? Watch what you're doing there carefully. How do you deal with that -1? These last few are kind of really similar, although a couple of them have fractions in them. I put a lot of negative signs, so watch those. So, if you do this assignment, as you do it, you do question 1, you do this question, and then you graph the question and your answer. If they're right, you move on. Next one, you graph the question and the answer. If they're right, you move on, and so on. If this is easy for you, you check by graphing. If you get them all done, or maybe you make a little mistake, but you quickly find your mistake and you fix it, you're done your homework. If it wasn't easy, if you made a bunch of mistakes, or you're just not sure, or you really want a little more reassurance, then you can watch the video called Changing to General Form, and I'll go over some of these. I'll make up examples really similar to this and go over them. Okay, thanks. Hi. So if you're watching this video, it's because you wanted to see a few examples of some of these simplification questions. So I'll do some like these, where we've got things factored, and we want to simplify. And then after that, I'll do some where we've got equations in vertex form, in standard form, and we want to simplify. And I'll do some with some fractions and extra negative signs and stuff too. Okay. So we've got y equals, in the first one, 3x minus 2 times 2x plus 8. So that's what we have to do is multiply every term by every term in the first bracket by every term in the second bracket. So there should be 4 terms on the next line. 3x times 2x is 6x squared. 3x times 8 is 24x. Negative 2 times 2x is negative 4x. And negative 2 times 8 is negative 16. And then we just usually, if you're doing, oops, let's see, get that back on the screen. We've got like terms here, 2 different x terms. So we'll just group those. So 24x subtract 4x gives us 20x. So then to check, and you should do this every time. I'll only do it a few times because you can do it on your own without watching me do it. I'm going to graph this line. So we've got 3x minus 2 and 2x plus 8. And then I'm going to graph my simplified version. So it's 6x squared plus 20x minus 16. Maybe before I go any further, I should just make a comment about these negative signs. There's 2 different negative signs on the calculator. Let's see. So there's this one here. This is a subtraction sign. So if you're subtracting, as we are in this case, we have 6x squared plus 20x subtract 16. You're going to use this one. And if you want to make it a negative number, you're going to use this one down by the decimal point. So if you wanted to start off with negative 6x squared, then you'd use this one to start with. This one down here is smaller. If you press it, I'm just going to press it so we can see the difference. It looks like that. Okay, so I'll delete that. Okay. There's the first graph. That's actually just 2 parts of a parabola, because the vertex is down here somewhere. And there we go, it finished thinking, and that's all we've got. So there's 2 graphs right on top of each other. So that's correct. Okay. So I won't do that every time. I'll leave you to check them on your own in the calculator if you want. But when you're doing your own, you should check them every time. Okay, second example. There's 2 options here. You have 3 things that you're multiplying. The negative 2, the x plus 1, and the x minus 6. So you can either multiply one of these brackets by negative 2 right away, or you can multiply the 2 brackets together first, and then multiply everything by negative 2. That's what I'm going to do. I don't know, I just like it better, but you should get the same answer. The one thing you should not do is multiply everything by negative 2. If you multiply this bracket by negative 2 and also this bracket by negative 2, you actually are ending up multiplying things by 4, which isn't what you want. So you can do the order that you want. So we've got negative 2 times x squared minus 6x plus x minus 6. And then you can multiply by negative 2 now, but it's easier if you collect your like terms first. X squared minus 6x plus x, so that's minus 5x minus 6. And now I'm going to multiply everything by negative 2. So negative 2x squared. Negative 2 times negative 5x, so that's going to be positive 10x. Negative 2 times negative 6 is going to be, again, positive plus 12. As I go through here, I mean, I may well make... just like everybody else, I make little mistakes here and there. So if you think that really there's a mistake on the video, then just ask me about it tomorrow in class, because there may well be on any of these ones. Okay, so this is the same deal, except that we've got 1/3 instead of negative 2. And sometimes people get a little unsure about that. So here we'll just multiply things out in the two brackets just the same way. So we've got x squared minus 5x plus 3x minus 15. And then I'll collect my like terms there before I do anything else. So that negative 5x plus 3x is negative 2x. Subtract 15. Okay. So 1/3 of these, we're going to multiply 1/3 times everything. So we're just going to have 1/3 x squared. 1/3 times negative 2, it's got to be negative. And 1/3 times 2 is actually just 2/3. And then 1/3 times negative 15. It's negative 15 thirds. If you want, we can do this over here. Negative 15 thirds. But that's negative 15 divided by 3, right? So this is equal to negative 5. So this is positive times negative, so it would be negative 5. One thing that's worth mentioning right now is just how to do some operations with fractions on the calculator. So I just pressed quit there, second and then mode. So if you want to do calculations with fractions, you should always put your fractions in brackets. For example, say you want to do 2/3 times 4/5. Okay, so you put each fraction individually in brackets. And we get this number. But really I don't want a number that's 0.53 repeating. I'd like to have that as a fraction. So conveniently these calculators will do that for us. So you press my favorite button on the calculator, because it's called math, which seems like a good button for a calculator. And then you actually just press enter twice. You want to choose fraction, and then you press enter again. And so that'll tell you that's 8/15. So that's really useful. You can use that whenever you want. Okay, so there's my 3 examples like that. If you need more, I'd be happy to give you more at school. You can also just make them up, right? Make them up, and then you graph the first line, graph the last line, and see if you get the right answer. Oh, this, by the way, if you want to put this in the calculator, you'd open brackets and do 1 divided by 3, close brackets, x squared, minus, and then in brackets again, 2 divided by 3, x minus 5. Yeah. So I'm going to go through these examples. I'll go a little bit quick, but feel free to pause if you want to just stop and think about something here. So here's an equation in standard form. Y equals x minus 3 squared plus 5. So I strongly suggest that when you have x minus 3 squared, that means x minus 3 times x minus 3, right? So you actually write that. Probably half the time if people don't write that, they miss one of the terms. Okay, and then we just multiply it like before, so we have x squared minus 3x minus another 3x. I'm going to do that one in my head, so that's minus 6x. And then negative 3 times negative 3 is plus 9. And then don't forget, sometimes people forget that plus 5 at the end, so they just don't watch that. And then if I'd done those, if I'd written those each out, I'd have to collect like terms in the middle. Then I've got like terms here as well. So x squared minus 6x plus 9 plus 5 is 14. And again, you can graph both of these. This should give you the same graph if I haven't made any mistakes. So here it's a really similar deal, except that there's this negative 2 and the x minus 1 squared plus 6. So careful that you don't sort of do what I said in the other example where we multiply 2 by the negative 2 by both brackets. And that is effectively what will happen if you multiply this negative 2 by the x plus 1 right now. So you've got to square the x plus 1 on its own. The order of operations says that only the x plus 1 is squared. So we've got that. And now you can multiply these out in whatever order you like. I like to do these first. So x squared plus 1x plus another x is 2x. 1 times 1, remember, is 1, not anything else, plus 6. And now I'm going to multiply everything in the brackets by the negative 2. Be careful you don't multiply the 6 by the negative 2. So negative 2x squared minus 4x minus 2 plus 6. And then I'll group those. So I've got negative 2 plus 6 is plus 4. Okay. So I'll do just a couple. I got, I think, 2 examples on the back of this. Okay. So this is the same, but we've got another pesky third in here. So deal with that in a bit. Let's do the x plus 4 times x plus 4. If you're skeptical about this, if you really want to multiply the 1/3 times x plus 4 and then square it, you can try it and then graph both, and you'll see that it comes out wrong. The graphs will look different, which means that it's wrong. Okay, and then here I've got x squared plus 4x and another 4x. And feel free to do that in 2 steps if you want, but I'm going to write it in one as 8x plus 16, and then I close brackets and I've got minus 2 here. So remember that then 1/3 is only multiplying the things in the brackets. So I've got 1/3 x squared. 1/3 times 8 is just 8/3. And then 1/3 times 16 is just 16/3. And we just can't simplify those because there's no common factors between 8 and 3 or between 16 and 3. Subtract 2. Now, there's a couple ways to do that. We have to group these. 16/3 minus 2. So one way, 16/3 minus 2, is we can just change this into thirds as well. So how many thirds is 2? If you think of 2 wholes, give you 6/3. And then 16/3 minus 6/3 is 10/3. If you're not comfortable with that, I mean, you should practice getting comfortable with that, but if you're not right now, you can do this. So on your calculator, open brackets, 16 divided by 3, close brackets, subtract 2, press enter. You get this. This isn't super useful, but then if you press math and then enter twice, it gives you 10/3. So if you need to, do that. So then our answer here is 1/3 x squared plus 8/3 x plus 10/3. Okay, and I'll just do one last one. So we've got -1/2 again. And again, I need to write this out twice, because the order of operations says exponents comes before multiplication. So that gives me x times x is x squared, x times -5, -5x, and then another -5x here, minus 10x plus 25 plus 4. Alright, and then -1/2 times that. Because -1/2 equals 0.5, -0.5. Let me write that neater. -1/2 equals -0.5. So if you want to use 0.5 here, or 10.5 or whatever we've got, that's fine. That's okay. But I need to point out up here, where should I write this? 1/3 is not the same as 0.3 or 0.33, or you can write a whole bunch of 3's, and it's not the same thing. It's close. It's really close. But if your decimal is not, if it's a repeating decimal, if it's not a terminating decimal, if it goes on and on and on, then you have to use the fractions in the answer. But here, if you wanted to, I'm going to use the fractions, but if you wrote 0.5, that would be perfectly fine as well. So -1/2 times x squared is -1/2 x squared. -1/2 times -10, so it's plus, and then a half times 10. You could do a half times 10 in your calculator and check if you weren't sure. Remember to put brackets around a half. Or you can think, well, that's just a half of 10. So that's 5. And then a half times 25, so it'll be negative. A half times 25 is going to be 25 over 2. Because 12 and a half. Plus 4. So 25 over 2, you could either do all this in fractions, you could do it similar to what we did up here, you could do it in your calculator, or you can think that that's negative 12 and a half. Maybe it's in this case, maybe it's easier to write that. And again, because it's exactly the same thing here, either one is fine, it doesn't matter to me which you use. So negative 12.5 plus 4, it's going to be negative 8.5. And then I suppose we should either change this to a fraction or change that to a decimal. It's nice to have them both the same. You could put 8 1/2, or you could put 17 halves as well. Okay, so if we graph this in a calculator, we graph this in a calculator. If I haven't made any calculation mistakes, those should come out exactly the same. Okay, so remember again, your homework is on the first video, at the end of the first video. I think this is it here. And you're done when you're comfortable with all those, and you can do them quickly and easily. Alright, bring your homework to the class tomorrow. See you tomorrow.